Alright, so turn to page 2 in the new packet. For counting principle, I drew a red X for multiplication because the fundamental counting principle has to do with multiplying. For experimental probability, I wrote what happens because that's what actually happens in an experiment. Fair game. So if you roll a number cube, you have a fair chance of landing on any side. For outcome, I put heads because if you flip a coin, one of the outcomes could be heads. The sample space of that could be heads or tails. Theoretical probability is what should happen, or I'm going to make a note what you think will happen. So TH for think, and then TH for theoretical. And then finally tree diagram, which we're going to talk about today. And down below I have some events. So win the lottery, it's not quite at 0 because it could happen, but it's on the lower end, close to impossible to occur. Math homework, I put that on the upper end, so more certain to occur. But with probability, you could see percents, decimals, or fractions. Alright, so page 3. So tree diagrams are nice visuals that are used to illustrate events. They show all the possible outcomes in a situation or experiment. So if you look below, if we flip a coin, you could either land on heads or tails. So that would be your sample space, heads or tails. If you do it multiple times, here's a tree diagram to show what that could look like. You could have 2 heads if you flip it twice. You could have heads and tails, tails heads, or tails tails. Note though, the tree diagram could also be drawn horizontally. This one's vertically up and down, but it could also be horizontally. So number 1, getting tails on both flips. That only happens here. So that would be 1 out of 1, 2, 3, 4 times. So 1 out of 4, or 25%. Getting at least 1 tails. 1, 2, 3, so 3 out of 4, or 75%. So Kirsten owns a black and blue pair of jeans. She has red, green, and yellow shirts. How many possible outcomes could she make? So I made this tree diagram horizontally, so I started by putting it in order, black and blue pair of jeans. Then I added on red, green, and yellow. To determine the number of outcomes, you want to count this farthest away branch. So 1, 2, 3, 4, 5, 6. So there are 6 different outcomes. Alright, number 2. So George flips a coin 2 times and then rolls a 6-sided number cube. What are the possible outcomes of these events? Alright, so your 2 outcomes for a coin would be heads or tails. Then he rolls a 6-sided number cube, so assuming that's fair and it goes 1 through 6, I put those branches underneath heads and tails. That gives me a total of 6 plus 6, so 12 different outcomes. Try numbers 1 through 5 down below and then check yourself with me. Alright, so there are a total of 12 different outcomes, so 3, 6, 9, 12. How many combinations would there be if they add another flavor? So you'd add 3 more for the sprinkles, nuts, and strawberries to cone, so 12 plus 3, and then 3 more to the cup to get 18. How many combinations can Jane get with vanilla ice cream? 3 here, and 3 here, that gives you 6. How many combinations if the ice cream shop runs out of nuts? So do 12, the total, minus the 1, 2, 3, 4 to get 8. And then finally, how many combinations are there with chocolate and strawberries? So here's 1, and here's the other, so 2. So number 3 says make a tree diagram and you take a letter from the word math, so M-A-T-H, a digit from 1, 2, 3, so 1, 2, 3 all the way across, and then from underneath numbers 1, 2, and 3 you put a period or exclamation mark. Some of those are kind of hard to see, but I put periods and exclamation underneath every number. So how many outcomes are there? So count and see this farthest branch. 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I'll leave these other two problems for your homework. Go ahead and look at page 6. Alright, so fundamental counting principle will save you a lot of time. So what you have to do is you use multiplication instead of the tree diagram to determine the number of possible outcomes. So it's a shortcut for finding the number of outcomes, but the issue is this right here. So yeah, you can quickly determine how many outcomes there are, but you will not be able to see what the different combinations are. So look down below. There are 1, 2, 3, 4 types of steaks. There are 3 ways they can be cooked. Then you have 4 different types of potatoes. So rather than making the tree diagram, just multiply together. So 4 times 3 gives you 12, and 12 times 4 gives you 48. So there are 48 different outcomes at this steakhouse. Example 2. So to make an ice cream sundae, there are 2 serving sizes times 5 flavors of ice cream times 4 different toppings. So multiply that together and you would get 40 outcomes. So to be honest with you, I like to use fundamental counting principle as a way to always double check myself on these tree diagrams. Alright, example 3. According to the table, how many different sizes of junior jeans are there? So there's 3, 5, so that's 2, 3, 4, 5, 6, 7. So 7 different sizes. Then there are 3 different lengths. So we're going to multiply 7 times 3, and we get 21. So number 4 says draw a tree diagram to help you find the number of different size and length combinations. So pause your screen for a second and go ahead and try that, and then check yourself with me. Alright, so look, I abbreviated here, and again I put it in order, sizes and then the lengths. So 3, 5, 7, 9, 11, all the way up to 15. And underneath I use P for petite, R for regular, and T for tall. So I have 3, 6, 9, 12, 15, 18, 21. So there are 21 outcomes. So again, the tree diagram gives you a nice visual, but fundamental counting principle certainly saves you a lot of time. But if you use one, you could use the other as a check step to make sure that you got it right. Alright, so on page 8, Sally's Ice Cream Parlor has 5 types of ice cream, 3 kinds of cones, and 4 different toppings. So which of the following shows the correct way to find all the possible combinations? So I'd get rid of the first, because that has addition. Get rid of the next, because that also has addition. So anything that's addition, get rid of, because it should just be multiplication. So technically you could use 5 times 3 times 4. That would be the correct one. 5 times 12 would give you the same answer because 3 times 4 is 12. But let's just stick with the 5 times 3 times 4. Number 2. So there are 3 kinds of shirts, 3 kinds of pants, and then 3 pairs of shoes. So get rid of these addition, and we're left with 3 times 3 times 3. Look at number 5. So the possibility of winning a state lottery game where the winning number is made up of 4 digits from 0 to 9 chosen at random. So I'm going to take a second and write out numbers 0 to 9 so I can check out my sample space. Okay, so that gives me 10 different possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to say 10 times 10 times 10 times 10. That gives you 10,000. Go ahead and try page 9 and then check that with me. Alright, so make sure you have everything right. So for soft drink, I made a note that would be any of the sodas above. It's like Coke, Pepsi, or Sprite. So there are 3 types of sodas and 3 different sizes. So 3 times 3 times 6 times 3, you get 162 outcomes. For sandwich, fries, and milk, 6 sandwiches, 3 sizes of fries, 2 sizes of milk. So 6 times 3 times 2, and you get 36. Salad with dressing and tea, 3 salads, 3 dressing, 3 times 3, and then 2 tea sizes, so times 2 for 18. And then for D, 6 sandwiches, 3 salads, 3 dressings, and 2 coffee sizes for 108. So on page 10, try numbers 2 and 3 and then check that with me. Alright, so number 2. So a vowel would be A and E, then your consonants would be B and K. So I made my tree diagram here. So number 3, she tossed a coin 3 times. So here's the first toss, heads or tails. She tosses again and then again. So the question says how many different outcomes are there? So 2, 4, 6, 8. You can check that using fundamental counting principle. So you have 2 different outcomes, heads or tails, times 2 different outcomes again, times 2, and that does give you 8, so that's right. Alright, finally try number 4 and then check yourself with me. Alright, so mine got kind of messy, but as you can see you have 2 different outcomes, true, false. I did that 4 different times, and that gives me a total of 16 different outcomes. You can check that, 2 times 2 times 2 times 2, it gives you 4 times 4, so that is 16. So that means we got it right.